Welcome to Two Projects. In this video, we are going to explain the project Ship Detection based on faster RCNN using range compressed airborne radar data. Introduction. The primary objective of this project is to develop a ship detection system for sea monitoring using faster RCNN, that is region-based convolutional neural network with range compressed airborne radar data. Sea monitoring plays a critical role in ensuring maritime safety and preventing activities like illegal fishing. Therefore, a more robust ship detection system is needed. Traditional techniques such as AIS and marine radar face limitations in detecting ships without AIS systems. They might also be prone to false ship predictions when evaluating radar signals using constant false alarm rate. So, in this project, we introduce faster RCNN, a deep learning based approach for ship detection. It leverages range compressed airborne radar data obtained from airborne flight radar signals. This approach eliminates the dependency on AIS installations on ships and utilizes both time domain and Doppler domain data for improved ship detection and classification. And the beneficiaries of this project are marine authorities, sea safety organizations, and any entity involved in sea monitoring. By providing a more reliable and AIS independent ship detection system, this project enhances maritime safety and security, contributing to the well-being of both the marine environment and those who rely on it. Objective of the project. So, as I mentioned earlier, the primary aim is to create a ship detection system utilizing the faster RCNN algorithm. This system enhances sea safety and security by identifying ships in maritime environments. And to improve ship detection, the project incorporates the use of airborne compressed radar data obtained from flight radar signals. This data includes both time domain and Doppler domain information, enabling more accurate ship detection. And by training faster RCNN on both time and Doppler signals, the project achieves more precise ship detection and classification. Faster RCNN's region-based approach ensures accurate identification while avoiding false detections. Requirements needed to execute this project are software requirements. Software of Anaconda, primary language of Python, front-end used is Flask, backend framework used is Jupyter Notebook, database used is SQLite, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Now we'll understand the working modules of flow of work. The first step is importing required packages. This step involves importing the necessary Python packages and libraries that are essential for this project. These packages typically include machine learning libraries like TensorFlow or PyTorch for building and training models, as well as image pre-processing libraries like OpenCV for handling image data. The second step is exploring the dataset. Here we load and examine the dataset. We check what data is available, its structure, and its contents. In the context of a ship detection project, the dataset contains radar signals and images. The third step is data pre-processing. Data pre-processing involves preparing the dataset for model training. This includes various tasks like resizing images to a consistent size, normalizing pixel values, handling missing data, and shuffling the data to ensure randomness. The fourth step is train and test split. After pre-processing, we typically split the dataset into two parts, a training set and a testing or validation set. The training set is used to train the machine learning models, while the testing set is used to evaluate their performance. The next step is train and evaluate ResNet 50. So in this step, we create and train a machine learning model based on the ResNet 50 architecture. ResNet 50 is a popular convolutional neural network model for image-related tasks. We train this model on the training data and then evaluate its performance on the test data by calculating metrics like accuracy, precision, recall, and F-score. And as an extension, we build and evaluate another machine learning model based on the VGG16 architecture. VGG16 is another CNN architecture that we can use for ship detection. We load the pre-trained VGG16 model, fine-tune it if necessary, and evaluate its performance on the test data. The next step is performance comparison. So after training and evaluating both the ResNet 50 and VGG16 models, we compare their performance. This comparison typically involves looking at metrics such as accuracy, precision, recall, and F-score to determine which model performs better for shift detection. And the project extends beyond model development by creating a user interface using the Flask framework. This interface facilitates user interaction, authentication, and input submission for predictions. And the next step is Flask framework with SQLite for sign up and sign in. So in this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. And in the next step, users provide input images through the front end. These images are pre-processed to ensure they are in a suitable format for input to the trained models. The pre-processed user input images are passed to the trained ResNet 50 and VGG16 models for shift detection. The models make predictions on whether shifts are present in the input images. And the final outcome is displayed through the front-end interface for the users to see. And this is comparison graph comparing the performance of extension VGG16 model and proposed ResNet 50 model. So in this graph, on x-axis I have algorithm names, and on y-axis I have performance metrics, accuracy, F-score, precision, and recall. So we can see both the models are doing well, and VGG16 is showing little higher accuracy. So we will use VGG16 for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have required dataset on which we will train the machine learning models. And this is models folder in which I have pickle, h5 and json files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is test images folder in which I have these images on which we will make predictions. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And this is notebook.ipynb file. This is a Jupyter Notebook file which contains combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it and open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. So after running the app.py file, the Flask framework will host the application locally at the default address, local host and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Now click on this. So here we can see a register link, click on it. So if you are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on login button. So it has redirected us to the shift detection page, and here we have to provide the input as image. Click on choose file button. So from test images folder, I am selecting the first image and click on open. So we have loaded the image. Now click on upload button. So it will take some time to process it. So we can see it has highlighted identified ship with prominent bounding boxes, categorizing them as ships. It is essential to note that scanning the entire image for all ships could be very time consuming. Therefore, we have set up the system to pause after detecting a single ship. This image was taken from an airborne perspective. Similarly, we can upload any image and make the detections. So the conclusion here is, the project successfully demonstrates the effectiveness of machine learning models including ResNet 50 and VGG16 in detecting ships from radar signals. These models achieve notable accuracy and precision in ship detection. Through a thorough performance comparison, it was determined that VGG16 has outperformed the other in terms of accuracy, precision, recall, and F-score. This insight is valuable for selecting the most suitable model for ship detection tasks. The implementation of a front-end interface using the Flask framework and user authentication via SQLite provides a user-friendly experience. Users can easily input data and receive ship detection results. And the project opens avenues for future development, including the optimization of existing models, expanding the dataset, and incorporating real-time data input for more practical use cases.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.